Okay, so this is a test for the Labyrinth piece. So currently what I have here is a ground rail around the centre with a conductive sensing tab for, there's 5 sensors in total. One is like the initial start sensor, which would be the start point of the labyrinth. And then we'd have sensor 1, 2, 3 and 4 as if you were moving in through the labyrinth. The first one will be the first one. So when you pass sensor 1, that LED corresponding to that sensor will light up, or the LED strip corresponding to that sensor. When you hit sensor 2, the first set of LEDs will turn off, the next set will turn on, and so on and so forth. So what is happening here at the moment is it's in an idle state where it's kind of blinking. So it's kind of an invitation to come forward and play. This is the start touch sensor here. So when it senses that there's somebody wants to play, we can notice here that the blinking has turned off. It's now in a kind of a standby state. So as you would move from the start position to sensor 1, which is here. So when I press sensor 1, we have the first strip of LEDs lights up. When I press sensor 2, the first set turns off, the second set turns on. Sensor 3 is over here. Sensor 3, sensor 4 is here. It's actually just the onboard LED turning on at the moment, and that turned off there, which is exactly right for the moment. But what will happen is with a master and a slave, at this point the master will send instructions to the slave to start its sequence to continue on from sensor 4 to 5, 6, 7, 8 and work back from 8 down to 5 again, then a message back to the master. So the master at that stage, on receiving a message, will come into a reverse state. So this is sensor 4 reverse, which is now on. Sensor 3 reverse will turn that one off and this one on. Sensor 2 reverse is here, and sensor 1 reverse is here. And when we come back to the beginning point, everything is off again, and it actually resets then again with its blinking LED as an invitation to come forward. So that's kind of it for the moment. There's a few different resistors in here. I've been testing out a few things. The resistance values certainly don't need to be as high on the LilyPad. It's a bit slower actually as well, so I think I can reduce those resistance values down. The lowest one I have in here at the moment is 3.3 mega ohms. It's actually a lot slower than on the Arduino. It's probably due to the clock speed also. It's half the clock speed, 8 megahertz compared to 16 on the Arduino. So I need to try and speed it up a little bit. So I think I'll be reworking or rethinking the resistor values I have in the setup altogether. But that's it for the moment.